guys, welcome to PV Studies. Now we are going into a physics concept, that is vectors part 1. Now going into the concept, what is a quantity? Why we are learning quantity? Our topic is vectors. A doubt may arise in your mind. Yes? See. Now first, it is a quantity. Quantity is divided into two quantities, that is physical quantity and non-physical quantity. Again, this physical quantity is divided into two forms, that is vectors. Wait, we can write like this. First, scalars and vectors. Understood? Now why we are discussing about the quantity? See the definition. Quantity means size, amount, vastness, magnitude, or simply stated as how much or how many. See, size. What is meant by size? Size of this marker. If I ask you what is the size of this marker, you may tell 5 centimeters or 10 centimeters something. See, this 10 centimeters. This is the size. Yes, this is one quantity. We can tell this is a quantity. Okay. Next, amount. A milkman daily comes to your house and pour milk and goes away. See, now the amount of milk in your can is 1 liter, for suppose. This is amount. Means this is also a quantity. Vastness. Vastness means deep, means vastness of Atlantic Ocean. Vastness of Atlantic Ocean means something meters, means 1000 we can take. I don't know approximately, I don't know exactly. 1000 we can take, 1000 meters. Magnitude, this is also similar to these three. Okay, magnitude means 5, 10, 1000, like that only. That is only quantity, or simply stated as how much or how many. Means anything we can take. If you are feeling happy, how much happy you are feeling you can tell. No, how much or how many. Happiness, sadness, happy, sad, any feelings, or like 1 meter, kg, liter, anything. These all comes under quantity. Now, these all comes under the quantity. Now, what is a physical quantity? I told you, quantity is divided into two types, that is physical quantity and non-physical quantity. Once please take a look at this. Now, what is a physical quantity and non-physical quantity? I told you that quantity is divided into another two quantities, that is physical and non-physical quantities. Now, the quantity, what is a physical quantity? The quantity which is measurable is called a physical quantity. In the quantities, I told you what are the quantities? Happiness, happy, sad, otherwise means these all we can take feelings. These all are feelings, or meter, kg, liter, etc. Like that. These are units. These all are quantities. Yes, these all are quantities. In these quantities, which are measurable, means we can measure our feelings. No, happiness, sadness, anything we can't measure. So, which are measurable? 1 meter or 1 kg or 1 liter. These are measurable quantities. So, these are known as the physical quantities. Examples of physical quantities are meter, kg, liter, etc. Now, non-physical quantity means opposite of physical quantity. The quantity which cannot be measurable is called non-physical quantity. See, the quantity which cannot be measurable means we can't measure, like happiness, sadness, anger, those are Those all we cannot measure. Those are feelings. Yes. Now examples here: happy, sad, anger, and etc. Now I told you that quantity is divided into, once understood, please take a look at this. Now, what is a scalar? I told you that quantity is divided into physical quantity, non-physical quantity. Physical quantity is divided into scalar and vector. Yes. Now, what is a scalar? A physical quantity that has only magnitude and no direction is called a scalar. Means, for example, take distance. Now, east, west, north, south. You traveled 5 meters east. What is the distance? I asked you what's the distance. Then you will tell 5 meters. If you travel 5 meters north, again I asked what is the distance. You will tell 5 meters. You travel west 5 meters. Travel south 5 meters. In which direction also you travel, the magnitude means here 5 meters is constant. So now if you travel 10 meters, now magnitude is changing. Yes. So a scalar, a physical quantity that has only magnitude and no direction means it has only magnitude. It does not depend on direction. That is scalar. Now what is a vector? A physical quantity that has both magnitude and direction is called a vector. Now you will understand the difference between a scalar and a vector by explaining the definition of vector. Okay? See, now again. East, west, north, south. Yes? South. Now you traveled 5 meters east. Now I am taking east and west first. We will take. This is east, this is west, this is horizontal. Now you are traveling 5 meters east, means plus 5 meters I am taking. If you travel 5 meters west, minus 5 meters I am taking. The direction is changing. Here magnitude is also changing. Yes, the vector is changing. Yes, so a physical quantity that has both magnitude and direction means it depends on both magnitude and direction, then we call it as a vector. Examples of scalar are distance, time, energy, temperature, etc. Okay. Now here displacement, force, velocity, acceleration, etc. Understood the difference between scalar and a vector? A physical quantity that has only magnitude. Here we will consider only magnitude, no direction. It does not depend on direction. That is called a scalar. Examples of scalars are distance, time, energy, temperature, etc. Now, what is a vector? A physical quantity that has both magnitude and direction is called a vector. Means it depends on both magnitude and direction. Here, the examples of vectors are displacement, force, velocity, acceleration, etc. Understood? Please take a look at this. Now, here I forgot to tell you about one thing, that is, what is the vector definition? A physical quantity that has both magnitude and direction. Up to that only I told you. Here, up to here only I told you. Magnitude and direction is called a vector, I told you. But a physical quantity which has both magnitude and direction and obeys parallelogram law of addition. This we will discuss in the later part. Okay, parallelogram law of addition is called a vector. It should have both magnitude and direction and should obey parallelogram law of addition. That is called a vector. Okay. See, now if I take two examples, energy and temperature. Energy and temperature. These two should be vectors according to the before definition. Means up to both magnitude and direction. But these don't follow the parallelogram law of addition. Okay. Parallelogram of law of addition means I will tell you in the latter part of the video. Okay. Now note point. The magnitude of a vector is always taken to be a non-negative number. Non-negative number means 0, 1, whole numbers. Whole numbers, non-negative numbers means it should not be negative. But before I told you displacement. 5 meters you went east means that is 5 meters. Now you came 5 meter west. Now we can tell that is minus 5 meters. How? Here magnitude is here magnitude is negative now. Then how can we tell this point means here this is 5 meters and this is minus 5 meters. This is east, this is west. Yes. Now see, 5 meters east means here minus 5 meters west. Minus of west means opposite of west. That is east. For indicating the direction only, we are keeping the minus sign here, opposite sign. So, the magnitude of this is, we will say 5. The direction is west. 5 meters west we can take. But here I am taking the respective point as east. I am taking east as positive. So, we can write minus 5 towards east. Minus 5 towards east. Minus of east means opposite, west. Understood here? Now, we are discussing, actually we are discussing about vectors. But why do we need vectors? Yes? Why do we need vectors? Why do we need vectors? Why do we need vectors means a vector is in the form n mu we can take. This physical quantity, yes, physical quantity is in the form n mu means numerical value. This is numerical value and this is unit. For scalar means only we can write numerical value and its unit. Yes. But for vector there should be a direction. What happens if there is no direction? We will see now. If your mother told, think this is your house. Your mother told to bring some vegetables from the market. The market, you don't know where is the market. Here is the market. Your mother told go 2 kilometers. Means this is 1 kilometer, 1 kilometer. This side 1 kilometer and straight 1 kilometer. Okay, 2 kilometers means like this and like this you have to go. But you don't know where is the market. So you went straight forward 2 kilometers. Straight forward 2 kilometers. There one person is there. You asked him, again you asked him, where is the market? Now from here, what is the distance of the market? 2 kilometers. Again he told that 2 kilometers. Again you went straight. Again still you went straight. Now Here one person is there. Here, no, you went straight here onwards. Here onwards, you went again straight 2 kilometers. Now, here you ask the other person that, where is the market? Now see, this is 2 kilometer, 1 kilometer, and here onwards 1 kilometer. How many kilometers? 2, 3, 4. 4 kilometers. You went again 4 kilometers straight. This is the problem. We have to know the direction because of this only. Means you have to know that if you know the direction, you will go like this 1 kilometer and like this 1 kilometer. If your mother says go 1 kilometer north and then turn to east, if your mother says, then you can go very nicely. But if you don't know the direction, you can't go anywhere. Means you can't do anything. Understood? Why do we need vectors? Understood? Why do we need vectors? This is the market. This is your home. You went first 1 kilometer. 1. Again 2 kilometer. Again 4 kilometer. This is the problem you should not face any time. By knowing the direction, you can go anywhere. Understood? Please take a look at this. Now we will discuss about the representation of vectors. Representation of vectors. How can we represent a vector? By an arrow. This is tail, this is head. This is tail of an arrow and this is head of an arrow. Okay. Now, the magnitude. See, we can represent here direction. The direction of the vector is eastwards. East. How can we tell the magnitude? The magnitude of the vector depends on the line. Means depends on the length of the arrow. Here, length of the arrow is more. Length is more here. Here length is less. Means this is the greatest vector. Here magnitude is more, here length is more, and here length is less. Length is more means magnitude is more. Length is less means magnitude is less. We can simply write this vector as, for suppose A, means A bar we can write. For suppose this is A, then we can write A bar. The magnitude of the vector is modulus of A bar. Understood? Modulus of A bar or A. Here we can write. Understood? This is magnitude and this is magnitude. This is magnitude plus direction. This is magnitude plus direction. As this is A bar. We can write this vector as A bar. See. Now, if I am taking a vector 5 meters due east. This is vector A bar. Now, this is due east. Now, how can we write? A bar is its direction and modulus of A bar is its magnitude. To show you again, I wrote this. Okay. This is magnitude plus direction. This is magnitude. Understood? Now, another note point, that is, understood? Please take a look at these ones. Now, another node point, that is all vectors are quantities. All vectors are quantities. Yes, but all quantities are not vectors. Are not vectors. See, how can we tell this? Okay. Before I told you two examples, energy and temperature. Okay. Here energy. First we will take the example energy. It is a vector. It has direction and magnitude, but it does not follow parallelogram law of addition. So these are not vectors. All vectors are quantities. All vectors means take for suppose displacement. Displacement is a quantity. Yes, we can write. Otherwise, velocity. Velocity is a quantity. Okay. And weight. Weight is a quantity. But not only energy and temperature, any quantity you take. For suppose distance I took. This is a quantity, but this is not a vector. And another example of scalar, okay, mass. Vector. Mass is a quantity, but not a vector. Same for scalar also. All scalars are quantities, but all quantities are not scalars. Understood? Here scalars also can come or vectors also can come. Okay? We can write here vectors also. Means I am not telling that scalars and vectors are not equal. Here anything we can write. This sentence is satisfied. Scalars cannot be vectors and vectors cannot be scalars. Okay? Understood? Please take a look at this. Now, see here. Scalar quantity is added according to ordinary rules of algebra. Or what is ordinary rules of algebra? Means addition, subtraction, multiplication. Added, no? Added means addition. See. Now you're going 5 meters or 10 meters east. 10 meters east you are going. Again you went 10 meters again east. This is 10 meters. This is 10 meters. Now scalar. Scalar means distance. Here displacement won't come. Means distance only. 10 plus 10, 20. It does not depend on direction. No? So 10 plus 10, 20. Okay. Now again 10 meters east you went. 10 meters west. Now the distance travelled by you means again 10 plus 10. It does not depends on direction. Scalars does not depend on direction. Like that 10 meters north, that is only 10 meters east, 10 meters north you went. Again 10, 10. 10 plus 10. 10 plus 10 how much? 20. Here direction is changing, but the magnitude is not changing. So scalar quantity does not depend on direction. Huh? So the distance travelled is 20. Okay. Now coming to the second point, vector quantities are added according to the Vector laws of algebra. Vector laws of algebra means parallelogram law. These all you will discuss in the latter part. Parallelogram law, triangle law. See here now, I will tell you small example. Now you came 10 meters. Otherwise take here instead of 10 meters 4 and 3. 4 plus 3 how much? 7. 7 meters. 7 meters. Everywhere 7 meters. Here also 4 plus 3 is equals to 7. 4 plus 3 is equals to 7. Anywhere these 7 meters only will be, because it does not depend on direction. Now vectors. Now coming to vector quantities. This is 4 meters. Again you travel 3 meters. 4 plus 3. Direction is same. So add it. 4 plus 3 7 meters. Okay. Now if you travel 4 meters like this and 3 meters like this. Yes. 4 meters you went eastwards and came back 3 meters westwards. Now what is the displacement? We should not tell distance, because distance is scalar quantity. Displacement is vector quantity. Understood? Okay. Now see. Displacement only we want. Distance is scalar, so we should take vector quantity, that is displacement. 4. Now I am taking east as positive. 4 minus 3. 1 meter. Okay. See again. East. Now it went north. 4 meters. 3 meters. Now the angle between east and north 90 degrees. Yes. Now by Pythagoras theorem, now by Pythagoras theorem, here what is the resultant, means how can we add here? Root over 4 square. What is the displacement? S displacement. How can we do it? Root over 4 square plus 3 square, that is equals to root over 25, that is 5. Yes. Here 5 meters means here, see, here when the both displacements are in same direction, means the both lengths are in same direction. Then 7 meters is the displacement. Now both lengths are different, so 1 meter. Now here also they are different. Again different. 5 meter. Why here everywhere constant, but here why it is changing? Due to angle. Angle is different. It is depending on direction. So when we are changing the direction, the angle is also changing. So the magnitude is also changing. Understood? Now you can understand why energy and temperature are not vectors. Once please take a look at this. Now you can understand why energy and what are the resultants we got? 7, 4 minus 3, 1, 5. Yes, this. But now see, and temperature or electric current. Electric current we will take. Electric current is depends on both direction and magnitude, but it does not follow parallelogram law of addition. So it is not a vector. Okay, electric current I am taking. 2. Okay. Here 2 I am taking. Here 3 means here if we add this it will come 5. Understood the scalar quantities? Once please take a look at this. Now electric current. What is the unit? Ampere. Yes. Here 2 ampere, here 3 ampere, here 5 ampere. Here think the angle is theta. Now I am changing the angle. See, angle is changed now. Now think this is alpha. 2 ampere, 3 ampere. Here the final resultant will be also 5 ampere. Same. The angle is changing, means the direction is changing, but here the resultant is not changing. So that is why electric current is not a vector. Understood? Electric current is not a vector. Understood? Please take a look at this. Completed? Hey guys, our topic is completed, means part 1. Part 1 is completed. If you like the video, then why are you sitting here? Edit చేసిద్దాం కానీ. Hey guys, our part 1 video is completed. If you like the video, click on the like button and subscribe our channel, and don't forget to hit the bell icon beside the subscribe button to get the updated notifications from our channel. Thank you. Have a nice day. Bye bye.